Let's tackle a classic physics puzzle involving electricity and geometry. We have a charged ring of radius r with total charge q, and a very long charged thread stretching from the center of the ring out to infinity. The thread has a charge density lambda. Our goal is to find the total interaction force between this ring and the thread. This is the kind of problem that looks scary because of the infinite thread, but it falls apart beautifully if we choose the right perspective. First, let's organize what we know. We have a ring, a thread, and we need a force. The trap here is trying to sum up the forces from every piece of the ring on every piece of the thread all at once. That is a double integral nightmare. So pause for a second. Instead of thinking about piece of ring acting on piece of thread, can we simplify one of these objects into a field? Which one has a simpler formula for the electric field along the axis? If you recall your electrostatics, the electric field on the axis of a ring is a standard formula. It points straight along the axis, which is exactly where our thread lies. This is our breakthrough. We can treat the ring as the source of a field, and the thread as a collection of tiny charges sitting in that field. Let's write down the field E of the ring at a distance x from the center. It is k times q times x, divided by r squared plus x squared to the 3/2 power. Now look at a tiny slice of the thread at position x with length dx. How much charge is in that tiny slice? Since the linear charge density is lambda, the charge dq is just lambda times dx. The force on this tiny bit is just charge times field. So dF equals E times dq. To get the total force, we just need to sum up, or integrate, these tiny forces from the center, x equals 0 all the way to infinity. Let's pull the constants k, q, and lambda out to the front. We are left integrating x over this geometric term. Pause here. Do you see a simple substitution that solves this integral? Notice that we have an x dx on top, which is the derivative of the x squared inside the bracket. So let's use u substitution. Let u equal r squared plus x squared. That makes do equal to 2x dx. When we swap this in, the integral becomes a simple power rule, u to the negative 3/2. Evaluating this from the start of the thread to infinity gives us a clean result. The final interaction force simplifies to k times q times lambda divided by r. Or if you prefer epsilon naught, q lambda over 4 pi epsilon naught r. Does this make sense? If the ring gets bigger, larger r, the thread is farther from the ring's charge, so the force drops. Correct. If the charges q or lambda increase, the force increases. Also correct. You didn't just integrate a function,